Okay, this is Derwin King with Sampson Community College, and we're with the motor controls class, ELC 117. We're doing the recording here for anyone that may be home due to quarantine or other circumstances. But you can see the recording later on and try to see what we're doing and participate as much as you can from home. And I'm going to move the camera to wherever the students are doing something and explain what's going on. So we've got Taekwondo here and Alex, and they are hooking up a three-phase motor. When he completes it, then I'll explain what's going on. There's a 1 and 7 that's in here, and the 1 goes with that.
Oh, okay.
Yeah, it's okay. You can step on and let him redo it.
Okay. Yeah, that's what I was. Oh yeah, okay.
It's all new. It's all new. It's okay. The way the diagram reads is your incoming wire, number 1 over there.
Yes, sir.
It's going to join with a 1 and a 7.
And the 7. Okay.
Yeah, this in here. Yeah. You're probably thinking that 1 was that one.
That one, yes, sir. Yes, sir.
That 1 is in addition to another 1 that's in here.
Oh, okay.
Same thing as that one that we're working on.
All right.
It's the
Same
same
way.
thing. Yeah. You can also see it on this paper here.
Yeah.
Here, that's your logo to click up. Here, but this is the internal windings of the motor, of that motor. If you go high over this.
Goes with 1 and 7.
You got it right here, so go by.
It does.
I'm gonna just go ahead and get used to this. You know what I'm saying? The machine.
Yeah. For some reason, they made the sticker kind of in reverse image to where it should have been the 1 and 7, and then the 2 and 8, and then the 3 and 9.
Okay.
I would have had it flipped on the picture, but they didn't do it that way.
Okay.
For some reason. But as long as you match the numbers up, you're fine.
Yeah.
Pull your seat up, don't be time for save them knees. Man.
I already had surgery on both of them.
On the knees.
Yes, sir.
You might want to pull your feet up, save them. Man. I had total knee replacement on mine. 2019. Both of them. Major surgery. We got a good knee surgeon at the surgery in town, Dr. Huff, real good, but if they don't take care of them,
Yeah. Yeah. Y'all gotta excuse me, man. I'm sweating. I don't know why I'm so hot today.
working, man. Working.
Yeah. Very different color and everything.
Whoever may be watching, just see what he's doing. He's going on the low voltage hookup here and coming from his motor starter. From the motor starter, he's going to bring a number 1 that's going to join with a 1 and 7 in here. Number 2 from the starter is going to join with a 2 and 8 that's in here. And then the 3 from the starter is going to go join with a 3 and 9 here. There'll be 3 wires in each wire nut, and then 4, 5, and 6, they go together in a wire nut, and that's like an insulated set that goes to the power line. It's an internal connection in the motor. And that agrees with this on paper. The internal picture of the windings on the inside is called a wire wing on the motor. It looks like a wire on the inside. And this is the low voltage. It's the same exact thing. It's T1, 2, 3 comes from the motor starter. 1 going 1 and 7, 2 going 2 and 8, 3 going 3 and 9, 4, 5, and 6. They're together. What that does is it puts these windings in parallel. It puts 1 to 1 and 7. T1 goes to 1 and 7. And then the 2 goes to 2 and 8.
That's probably what it was.
Anyway, we're gonna take a look at what he's doing here. Then we'll confirm it in a second.
2 and 2 and
8. And 2.
You see, this is from a butterfly.
It is.
That's where I work.
You work in there? So when you doing third shift or something?
Yeah, second shift. Yeah, but I'm not hired football anymore. We just put I'm CDL.
You drive?
Yeah, and I put their feet.
I put their feed, pull their feed to a feed to a farm. Okay. Let's get it.
Right out of the butterfly treatment turkey.
Okay, I've seen that. So you go to the feed mill, you can take the farm.
About 6, 7 dozen a day. About 6, 7 dozen a day.
Hungry turkeys.
Yeah.
They grow them and send them all over the U.S. and they send them to the Middle East, England, all over the place. Each time you do it, time you get more comfortable with it.
Yes, sir.
And it's just going to be, you won't even really think about it. You'll just sit up there and you'll roll. It'll be a little quicker. When you go working somewhere in a plant or on a farm, you just want to make good sure that you know what voltage that you're running at, because that motor can go either way. And if the machine's running on high voltage, but you hook it up on low, it's going to burn the motor up. Okay. It's smoke. It won't be no good music. And vice versa, if the well, yeah. Okay. So let's just kind of verify what we have here. Is your coming in from the starter over there. The starter, we've got 1, 2, and 3 there. So number 1. The 1 is going right here to the 1 and 7. If you blue and pink, that's correct. Number 2 come out. Yes, sir. Number 2 come out. So he got a loose wire over here on the starter that came out. The bottom of the overload is fixing that. One important thing that you'll find out if this is when this is brand new to you, you got to have nice and tight connectors. If you got them kind of halfway tight, they're gonna come out. They'll wiggle out. You know. That starter each time it kicks in, it has a little bit of vibration to it. And it can kick in and out enough to where it can end up vibrating the wires and just pop out after a while if you're not tight. So it's number 2 from over here. It should go with 2 and 8. And it is. Got 2 and 8 right in there. Use the red and white. If it's number 3, the starter, it's going with 3 and 9. And it is. That wire nut, it just came off. Okay. Right. So you want to twist them to the real tight and then pull. Right. Sometimes the wire nuts still get to where there'll be a piece of broke copper wire in there, and then it was not going to break it. They'll get rid of it. Yeah. Yeah. Sometimes the spring is inside, they'll strip, and it'll break loose from the plastic, and it's not going to get tight. So they're not really made to use over and over like we're doing. They're made to use them one time a week long. What we do over and over again with these things, they just wear out.
It's gonna wear out. I mean, twisting one.
And this one got some in it too.
They wear out. They get to where they won't grab, you know.
Now, is there a code for what size you use?
There actually is. If you look on the container that come out of, there's a sticker on there that tells you that for the gallon, it tells you how many number 14s you can put in there, or how many 10s, or combinations of wires. So there is a code on that. It's actually printed. You go look at the plastic container that come out of, there's a sticker. And then next time you go say the Lowe's somewhere, look at the container, and the sticker's right on there. It tells you for the red ones, there's going to be a different number of wires you can put in there of different sizes, but it gives you the combinations on there that you can do. All right, so the one that we had trouble with was 4, 5, and 6, and you're good. So you got 4, 5, and 6 together, and that's the 4, 5, and 6 up in here. So he's good to go there. And now I'm going to examine the rest of the circuit. I don't remember if I checked the whole thing or not. So did you have your schematic? Is this yours? Yeah. Actually, you got the power up. So the 1, 2, and 3, and then that one from the ground.
So this one, the ground, the last one?
Mm-hmm. Yep. Your main power.
The ground one is the white one, right?
Green one.
Or green? Oh, yeah, okay.
Yep. Just go by the numbers. Them red things, they're jumpers. The jumper each set in pairs. So the first two terminals are the same thing, and so on. They look like car fuses, but they're actually jumpers. They look just like them fuses that go from the car that they plug in. It's actually a solid jumper wire. It makes it so you've got 4 screws that are the same thing, and you pop that in there, and if you plug on a hot wire in, then you've got 3 places you can get it from. But it goes to the circuit. Same thing on the yellow ones over there. It's a different kind that these actually screw in over here. They're screw in jumpers. So we're trying to use main power now. I've been dealing with running Zoom of the camera for about a year now, almost a year. This pandemic started. It was in the middle of this semester last year, about halfway through. That all of a sudden, it's like a light switch. All of a sudden, they said everybody's at home. Nobody comes. I said, man, how in the world are we going to do this? So they said you can use Zoom camera, and then they had a meeting over there. They showed us how to do it. I said, well.
These videos they post automatically on YouTube or you do it?
I still don't know.
Yeah, because I seen them on YouTube. I watch them.
Yeah,
Even if I come here, I still watch them.
That's good. That's smart. That's good. I've noticed that you've been doing that. That's good. That's good. That means you're really going to learn it good. It means you're getting it real good. Yeah. When you review something again like that way, it sinks it in better. That's the way I am. If you have time, it's a real good thing to do.
So we'll put the next one in right here.
Mm-hmm. The next group. It says 2 on it. Does it say 2 on the number?
Yes, sir.
Mm-hmm. That's it. So are you right-handed or left-handed?
Right-handed.
So it may work better if you use a screwdriver with your right hand. If you right with your right hand.
Okay. Now, because I couldn't really get over here because you was right there.
Well, let me move then. Yeah. Let me move. Yeah. You want to use your best hand there. You're it's gonna be stronger, you'll tighten it better. Okay. But when you record like this, you know, I'm live and before. Okay. And then you got the option to go back and see it again, and then somebody say this quarantine, they can see it whenever they can. He may be a doctor right now. He may be asleep, can't even feel so bad, he can't even, you know what I mean?
You know, I wish Mr. Miller would do that. Yeah, to the week that he was out. No, I was doing, he don't take the video.
I told him about it. I told him what I do. But it takes that extra time. Like last night, I taught a 4-hour class last night with Murphy. I recorded the whole 4 hours. Before I went to bed, I had it on YouTube. When you get done, it goes through a processing thing. It converts it to an MP4 file or video. And then once it does that, then you upload to YouTube. And I'll put the link in Moodle. Put the link in Moodle so somebody can click it. It's worth doing. It's worth doing. We get everybody through the program. Get him through this period here.
Ooh, I'm sorry, this is really hot.
Fogging up.
You get over here to work.
You're sweating a lot.
Sweating bullets.
He gets my ice water, man. He gets my ice water.
Yeah, I need that. Why you know this one?
And I see some sprigs in there. You see that sprig sticking out of that white one and out of that red one? And if they touch each other, it's gonna arc out. Yeah. It might not look like much, but it's enough. And if they touch each other, you'll have an arc plant. You gotta twist them real good. If they're bubbled up really bad, then we cut it and then we restrict it instead of it straight. You know, you have to do that sometimes. And you may have to open the terminal up, like I say, screw it open some so you get on there. That 12 was kind of tight in there, but it'll fit. That's the biggest wire that you can put in there if the maximum size can go in there.
Now, do I have to put it next to the real one? Or, no, right?
No, either one of the center ones, where that red jumper is.
Okay.
Mhm. Does everybody know about the worksheet in chapter 1? I got on the board there in Moodle for chapter 1. There's a worksheet. While you're waiting on me, you can go ahead and be knocking it out. Yeah. Okay, good. I'm putting stuff on the board behind you as far as assignments and then the wait list. You can use your smartphone to do it or a computer to do your worksheets. Yeah, and Daniel, if you're watching the video, whoever's watching the video, there's
What, they want to tighten up, by the way?
Yeah.
I put a worksheet for chapter 1 for motor controls in Moodle, and you go in, there's a section I have on worksheets. You can go in there and finish reading through chapter 1, and you can be doing that worksheet while you're out. You can contact me if you have any questions. I'll be glad to help you. My cell number is on the it's in my information. If you need to call, or you can email or text. Either one will be fine.
Mr. Dillon, how long you been teaching that here?
10 years.
10 years?
Mhm. Yep. The last plant I worked in, they went out of business, and then I had a chance to come out here and teach, and it worked out good. I got my degree out here back in 86, and then I spent 22 years working in plants, and then the last one shut down. College needed somebody to teach, and it worked out good. It's pretty amazing.
Your first time teaching?
Well, in a school, I taught them plant. I train people. I train new guys in maintenance. I was say the main trainer. So they get new guys in, they put them with me a lot of time, and I train, teach. And I actually started teaching when I was out here as a student. In my second year, I was tutoring. I got paid to tutor. So if you know a topic real good, even if you're a student back then, and they probably would let you do it now, probably tutor first year student and get paid. So I did that. I actually started teaching in 86 as a tutor. And then when I got into plants, the whole time I've been out in the industry, I would teach people stuff I knew, People that wanted to know it,
You teaching by different from high school. Because high school, you really got to tell them to sit down and listen.
Right.
You know what I'm saying?
Well, then here you got to tell people if you're in the classroom, you got to tell them, put your cell phone up, quit playing on the phone.
Yeah.
So it's a little bit like it. Some people still got the mentality, But when you're playing on that phone and you ain't paying attention,
Yeah.
it's like throwing money away. You're messing up, throwing away a good opportunity to learn that's something you make a lot of money at. You
Yeah.
can make a good living at it. I've made a good living at it for 22 years doing exactly what you're doing right now. That's exact thing.
Okay.
Yes, sir.
Yeah.
Yes, sir. I paid my bills, took care of family and everything, so, groceries, bills, car, truck.
Mm-hmm.
Yep.
I'm trying to get this right here too. We got to put that ground wire in.
Oh, it's not in?
No, this one at the bottom there.
Oh.
So you're fine right there. Those connections right there are fine.
This right here.
You'll have to put it up on there. Yeah. Phillips screwdriver. Yeah.
Just feel it.
Yep. We took that the ground wire for the motor. The motor has to be grounded up in there. Get the ground wire hooked up. And he's hooking it up with the other grounds over there off for the circuit. We have a single point ground. The meets at the transformer base there. And the motor and the transformer and the incoming ground, all that stuff comes together at one place there. It's on the foot of that transformer. Yeah. That keeps all your metal parts at earth potential, 0 volts. And if a hot wire hits the motor or if a hot wire hits that transformer, it'll come in contact with ground and it'll go ahead and blow a huge triple breaker real quick. And it'll go ahead and the circuit, the protection circuit will kill it.
Okay.
If these things are grounded. If they're not grounded, then the hot wire hits it, it's energized, and when you touch it, you're going to get electric.
You want that to happen.
If it's not grounded, yeah. Right.
You want that to happen.
Mhm. So now, let's examine the circuit to make sure you open this back up. Did I? Let's just make sure everything is wired correct.
Go with this.
Yeah. When a circuit's left in here overnight for a couple of days, This is rare, but occasionally somebody may run through it when we're not in it.
Yeah.
You never know. I hadn't had it happen a couple of years, but I've seen guys play a joke on me because if I do stuff, it's rare. I haven't seen it in a long time. Okay, so
Ain't nobody trying to play a joke on it.
like I say, it's been a long time since I've seen somebody pull something like that.
Yeah, it's a grade and everything.
So we're tracing the L1, that's good. And you have another L1 going to the fuse, that's good. And the fuse goes into the transformer, that's good. The L2 goes to the starter, that's fine. And then you have L3 going to the starter, another L3 going to the fuse, goes in, that's fine. But all these center ones, did you smoke them up? Okay, all right, good. Okay, that's fine. Going from here, X1, those, this loose, and then you see the wires sticking out. That's something there you want to be careful about there.
Then you say they can't pinch the wire either or something like that.
Well, you can't pinch the insulation.
Yeah, or do that, something like that. Yeah.
You won't have this copper up under there,
Yes,
but
sir.
you want a good tight fit.
Okay.
So the electrical connections, you want them to be clean and tight. You want them to, because machines can vibrate some, and that can make them just work loose.
Okay.
When it does, you get arcing going on, like a spark plug sizzling.
Yes, sir.
The arcing, then it develops into burnt connections, like sizzled and burnt.
Yes, sir.
And when it gets burnt, then it turns into high resistance, and then you losing power.
Okay.
And then your circuit ain't gonna work right.
Yes,
Your
sir.
circuit's gonna be blinking, kind of like lights blinking, like flickering.
Mhm.
And your motor will be flickering on, cutting in and out. And
Would that burn the motor up
it'll
too?
burn the motor up, burn the starter up.
Okay.
Okay. So that's nice. Yeah. It's still wiggling though. A little bit more. Oh, not too much. We're strict. That's fine right there. That's good. You want to go just enough so when you wiggle it, that it doesn't wiggle under the sound. But then small screws, again, they can spread it. They do drop their transfer. Okay, so that's good. Now, the X1 goes to the fuse. That's right. And then we're leaving the fuse and going to your start to your stop button. That's good. The stop button, you go to the start button. That's correct. And then you've got your holding contact. That's good. That's 13. And this is something here that you'll have to be here in person to see it up close, it being traced out. And so we traced it all the way there to 13. It's good. Now we're going to check leaving that start button. So you leave the start button, and you went to A1, and then you jumped to 14. That's leaving start, going to A1, and jumping to 14. That's good. And then you got the A2 going to 95. That's good. 96 takes it back to the transformer to X2. And then you have that grounded, that's exactly right. That looks like there's that's kind of loosey goosey there going on there. So you want to pull that out, retwist it, get up in there a little bit better. You want to take that out first.
Take it out.
Yeah, you pull it out because it's right dial up in there. Retwist that. Retwist the line in there. Keep your strands together. You want all the strands twisted together like you're doing there to go above the clamp saddle.
Right.
And nice and snug, yeah. Well, you can check it, just wiggle them when you're done, and you'll know if they don't wiggle under there, you know you're good. Now, that's it. That's that. If you do that every time, you're gonna be on form, man.
Yes, sir.
That's it. That's what you want. If you do that wiggle like that, you're good to go. That's perfect. But you can't get no better than that. That's it. That's it. Okay? So, this is actually ready to test. Got the single point ground there that's going back to the source. You can put that on there, button that up. Mm-hmm.
Do we have to keep these real tight?
Just a little bit, just a little bit.
Ain't tight to be good.
Finger tight's fine, but you're gonna go right back in there and stuff. You'll be having a jog switch and some lights. We'll put you some lights in here.
Yes, sir.
That's gonna be the next thing. We're gonna slide this over a little bit. You can see the. You can see the shaft. So one of you put your electrical gloves on and your shield. Got that cord locked right there. Put that in there. You need the safety glass things in this.
What am I doing, my place?
Got a flush, you can push in and turn. You gotta push in and turn at the same time. And you let go of it. We'll look at
Got a big head.
Yeah.
He said, yeah.
Going high here. You get your meter, and the easy way to do it is to put that lead right there, and hold the meter down here. Don't hold up in here because you hit that hold button. The hold button is something where if you go up to something and you can't read it, you hit the hold, and then it'll freeze the reading and it'll keep the point and stay on there. Even if you come off the circuit. But if you're doing it the wrong time, it's not going to read the reading. If it freezes what you do when you hit the button, you need to release that. So be careful about that. A lot of meters have that on there. So don't fold it. Well, first of all, you're not going to measure yet. You put that down. We'll start out just letting you run it. So start out, hit your start button, and let's watch the motor. Okay. And it's running good. And so we'll see the motor running, and now hit the stop button. We'll see which direction it goes. So it's going clockwise, isn't it? Clockwise facing the shaft. So what we want to do now is to reverse it because we're going to pretend that we got a fan that needs to go the other way. Okay. We got some fans, they pull air out of the room, some fans pull air in. And then some pumps have to go the other way or conveyors. So the way you got to do, what you have to do to reverse that motor, you should go out here and you pick any two of these and you work with them. And typically you do 1 and 3. And it can be done at the bottom of the starter, it can be done at the top of the starter, it can be done at the motor. Any place can be done as long as it's just for that one motor on. And you're not doing it up in here, it would affect the whole machine, it would affect other motors. So I'm going to ask you to do it at the top of the starter for a particular reason this time. So you can use a phase meter to do it. It'll show you the rotation. It's a meter to tell you what way the motor's going to go. And so we're going to let you lock it out. So if you lock this out.
Can I take this off?
Now, would that be the simple way or?
Whichever's fastest.
Okay.
We had this hanging up there.
You're going to go to the most convenient form. Whatever's convenient, just fast or whatever you get through. Most people are going to do it from right now. But I'm going to have you do it up here so that there's a special meter. I got a reason for doing it. Just kind of like this.
Yeah, I just did. I scored 100 on.
Right, good. So this meter here is the one I was talking about that'll tell you. It's a phase rotation indicator. It's got 3 leads on there. It's got a 1, 2, and a 3. And you can hook it up at the top of there, and this will tell you which way the motor will go before you even cut it on. It will predict and tell you. With an arrow, it's going to tell you which way the motor will go. So if you're going to reverse it,
Yes, sir. Yes, sir.
you can do go ahead and put 2 of them.
Okay.
You can. Most time people do 1 and 3, but if it's honestly doesn't matter. So you got do we have it locked out?
Yes, sir.
Very good. And also use the meter and let's make sure the circuit's dead, okay? Let's do that. So come on up here to the main, and I want you to go 1 to 2, 1 to 3, and then 2 to 3 with the meter. And be careful not to hit the purple button.
So I go to the inside?
Mm-hmm. Just make sure you get all the way in where the metal is. You can rotate that around, and what do you see?
Yeah, 0.
Okay, now go 1 to 3.
Still 0.
0.
Yes, sir.
And now go 2 to 3.
Still 0.
Mm-hmm. Now put one of them on ground and check 1 to ground, 2 to ground, 3 to ground.
0.
Mm-hmm.
0. 0.
Good. So that means you're fine. If you just check the phase to ground, and your zero should be fine. Okay. Now you can go ahead and switch them off.
So I got it. Okay. So when I switch them out,
You'll pick, say, just 1 and 3 and reverse 1 and 3. That's what's most.
oh, so just put 1 and 3 and 3 and 1. Oh, okay. Thank you.
And that'll make the motor go the other way.
Will you do 1 and 2? 2 and 1?
It doesn't matter which 2, just do 2, just only do 2 of them.
Okay. So same way you can do 2 and 3 and.
Yeah. Any 2. Any 2. The only reason I say 1 and 3 is common because you're going to get I think the starter that does it automatically. Some starters automatically do it. They do 1 and 3.
You need to get that today. 1:46. You got 10 minutes.
This type of starter here, it does it automatically. It's a forward and reverse starter. It's 1 overload, and that's something you can get right in a couple of weeks. And the way it does it is it jumps the incoming wires together, 1 to 1, 2 to 2, and 3 to 3, like normal. So that pound, but at the bottom of it, it's reversible. So inside that plastic there's copper bars in there, and it joins 3 to 1, 2 to 2, and then it's going 1 over here to 3 over there. So This jumper reroutes it when it leaves the vertical starter, goes through the jumpers that are in here, that are covered up, and it flips one and through that jumper set. So when you pull this one in, it flips them, and the motor goes the other way. But this does it automatically. What you just see, it does it through a jumper set that's in here. It's covered in plastic. It hooks 3 to 1, 2 to 2, and then 1 to 3. These are copper bars covered in plastic. And that top, it's joins them together in the same sequence up top. It puts 3 power wires in and it jumps 3 over here, but it doesn't switch through this. You'll do this in a few weeks. Okay. Okay, so we're going to unlock it now. Cut it on. This time, we're going to focus on the shaft.
So now you should turn this way.
It'll get counterclockwise now. Yep. It's a lot of stuff getting it off and on, but that's how you're going to stay alive. That'll help you stay alive.
Okay. I want to stay alive.
That'll help. It'll help. So, watch the shaft. It should go this way. I cut it off. You can see it go this way. See it? So what that does is it lets the fan do an intake versus an exhaust. Because some rooms will typically have a row of fans for intake and a row for exhaust. If you're ventilating it, or a conveyor, some conveyors run uphill, some run downhill, and some pumps go clockwise, some go counterclockwise. So if that motor's not doing what you want it to do, then that's how you reverse it. Okay. But it's predictable. It's predictable with a phase rotation meter what's going to happen. So we're going to take this meter right here and let you predict up here and over here when you switch to that, which way is the motor going to go. So it'll tell you up front. So you put the 1, 2, and 3 in there. You have to put, because of the size of these, you're going to have to move them like put 1 and then 2 down there, spread it way out, and then put 3 say up in here like that. Hold it. I'm gonna let you hold that there, Tom. You'll be careful. I've actually got the numbers in there wrong, I think. So you take them out and go 1, 2, 3. I didn't even pay attention to the number. So he's looking at the power. He's looking at the three leads of the meter for the power coming in. You might want to move that second one down to the bottom so it doesn't interfere with that one to the second group. So there you go. That's it. And then put your other one on the top of the third group. Okay. So it's telling you the motor's going to turn clockwise. See that? Yes, sir. So it's telling you which way the motor will go. If you hook it up in that sequence, if you keep that sequence, now pull your leads off. A while ago, you kept that same sequence over here when you made it match 1, 2, 3 over here. Okay. But I had you reversed at the top of this one, right? Yes, sir. Now you're going to see it be reversed now. So put your leads on the top of the starter, and then the meter's going to tell you that it's going to go the other way. So yeah, you have to go 1, 2, 3, and you may have to put one of them into the top to get them in there, because the guards on there, they're kind of big. So go number 2, go into the top so you can get in. See there? It's showing you it's gonna go the other way. See that? Okay. So it's telling you up front before you even run it which way it's gonna go. You got it? Yes, sir. So while we're doing this, so that we don't want to punt backwards and run it blind down the punt. Okay. So punts don't like to go back, they don't like to go the wrong way. Yes, they want to go one particular way, and you'll see that the direction on the punt casing. So on the main casing, where it rotates on the punt, there'll be some arrow that's stamped in there with the in the metal. And you're gonna, whatever that says, you need to make sure that power at the top of that starter agrees with that punt direction, so that you don't run that punt backwards and run it ground down. Now, for a fan, it's no big deal. If it runs backwards just for a second, it's no big deal. But for certain other types of motor loads, it does matter. So that's why it's important to do something like this if you can get a hold of them. Yes, sir. Right. And they're only around $300 something to get them. The company, whoever you work for, they could have one if they don't. So you ask them, so, hey, what would you like to be to know up front? I guess I'm flipping the coin, 50% if the motor's going the right way. Yes, sir. You know. So, okay, so that's good. And now next, we're going to let you do some, go ahead and run it again. So we're going to let you do some basic measurements with the regular voltmeter. So get your meter out.
Check your amps and everything.
We're going to check volts. We're going to do everything from the bottom of it now. And we're going to let you measure right here at the bottom. Go regular way, go phase to phase like you did, like 1, 2, 1 to 3, and then 2 to 3. And then check each one of those plans. And if you rotate the meter where we can see, kind of rotate around to the side. That's 1 to 2. Exactly. 1 to 2, then you do 1 to 3. Okay, all right. We'll see in a little bit. 2 to 8, that's good. And you go 2 to 3. Good, they should be very similar. And then check each one of them to ground. So now move out and put one of your probes on ground, and then go 1, 2, 3. Now it should be about 120 volts for each leg.
Now, does it matter which one you put on ground?
No, it does not. Not on AC, it does. For AC circuits, it don't. For DC, it does. This will say 121, right? This will say 192. That's fine. It's close to 120, so that's good to go. If it was a DC motor hooked up and you hook the leads up backwards on the meter, it would say a minus so many volts. If you take that meter and you go out to a car battery, you hook up the red and the black opposite on the battery, it will say minus 12 instead of regular 12. It doesn't mess the meter up, but it's just going to say minus. That's on a digital. If you use an old meter with a needle on it, it's going to make the meter peg backwards and damage the meter. If it's old with a needle on analog meter. But on digital, it ain't going to hurt. Now we're going to check the amps now. So if you take these leads and put them in the back of the meter, and you can do that. You're going to use fork now to check amps. So they'll go in from the bottom. So this, so that they're not going to be in the way. So put the meter on 8 amps. So we know these big gloves. Now, for checking amps, we're going to use the fork. You put the wire in there, you get it in the area where the line is, and it's going to tell you how many amps to pull. So you get right each one of these all the way up in there. So 1.8 amps. That's good. We're going to check each one individually, one wire piece. 1.7 and 1.6. Put it on there a little further. That's fine. 1.6. That's good. So if you want to know, is that reasonable, then you can cut that off. You want to compare it to your nameplate, the nameplate of the motor. And so that information is going to be I'm sorry. I'm trying to make sure that whoever's watching can see. You never know. That's fine. Running the camera is just another job in itself, sort of. So let's discuss right here. If you look right here, when you're running at 230 on low voltage, the full load amps would be 2.8 if you were connected to a mechanical load. If you were really pushing a pump with a conveyor, it would be 2.8. Well, in this case, you're around 1.7. You're less than that, so you're fine because the motor doesn't have a load on it. These are full load amps when you've got a mechanical thing to be driving. Okay? So as long as you're less than that, you're fine. If you were hooked up to a pump and you were drawing, say, 4 amps, way higher than that, there's something wrong.
Okay.
Which it could be the pump, something going wrong, or the motor, something going wrong, but you want to make sure that you're not more than this. When the motor's up top speed and it's leveled off. If you're running on high voltage, then the amps goes in half, 1.4, no more than 1.4 under full load. And so, that motor again, it will go, high or low based on the hookup. So you're good to go. And so the full load is 2.8, like that. You take that number and you come over here to set the overload. I'll give you a document for that from the electric code book. There's a dial on here that you can change the amp, the point where it trips. This got a range of 5.5 to 8 amps. And they make these in different ranges, lower range and higher range. So you set the overload to trip at a number that's 25% above this. You take that 2.8 there and you multiply it by 1.25, and then you set the overload over here according to that. And this overload is actually bigger than what that motor needs. But that's how you do it for actually knowing where to set that at. And then if something goes wrong and the bearings in the motor lock up or the pump locks up, and as you're drawing too much, this thing knows that it'll trip out. When it trips, it opens up that normally closed contact down here, pops it open. So it'll pop this here open like this. And I'll show you how that works. Go ahead and run it one more time. So if you're going along and all of a sudden the motor locks up or the pump jams up, here's what's going to happen. It's going to trip out, and I'm going to simulate it by doing this. You see the T shut in the window? The T, that means it's tripped. I just tested it. But when you try to cut it on, it won't come on. It won't come on because what has happened here is we've interrupted that neutral wave. So it's got power up to here, but it can't. The current can't flow through the coil. Like the circuit, it has to flow around and around. It can't because you cut loose the neutral wave.
Okay, now you say when there's something wrong with this, you say it's probably like a coil or something wrong with something in it. You say like
it can be a coil. We're going to get into that. The coil can actually go bad. They can actually burn open. It can. Yeah. That's one thing. Then the overload can go bad. Like right now, I've got it actually tripped right now. You can hit that blue button and make this here reset and reclose, and then it will run. So you hit the blue button, you hit click. It clicked, and then in the window, the T went away. It said it was tripped. That cleared. You cleared it off. And now it reclosed this so that when you hit the start button, it'll go to run. So you reset this. Now go ahead and run. And there it went. So that's what happens when the motor is just too much current. When these overloads sense too much current here, the overloads are in here, and then the OLs actually trip out this OL here. These control this. So when they get too hot, too many amps, they make that one thing pop open down here and then it pulls it off.
Now, if the coil goes wrong on this one, can that be fixed or best thing to do is replace the both?
You can put a new coil in it, or you can replace the whole thing. It's faster to put a coil in it.
coil is like a little thing like wrapped in,
Yeah.
like little wire, look like a little bit.
Coil it's easy to replace.
This one, yeah?
Right, that's a coil, but there's a small one inside there. We'll get into I'll show you how to do that.
Is this the reason why they wrap it around so many times?
Yeah. There's a coil, yeah. The coil is there's not. So when you put power, it makes it pull in like that. It goes from here like this.
Yeah, that's what you showed on the first video.
Yeah,
Got the coil like that. So when they go bad, it's not gonna pull in. This thing is like a magnet. It pulls, that thing, it draws an armature in, hook to it, and when it draws it in, the contacts can get closed inside there, so it makes contact close.
Can you tell us bad by the way it looks, or it won't look like it's bad, it just run bad? Like, you know what I'm saying?
You might know by the way it looks if it's burnt or smells burnt,
Okay.
but by measuring it with a meter, there's gonna be so many ohms of resistance in there, you can know that way by looking at it. By getting the resistance, we can put so many ohms, and we'll get into doing that.
My thing's glad on started.
You gonna lock this up, Mr. Jerry, you wanna go and lock it up?
Just go ahead and lock it out. You got real good questions, very good questions. So I'm happy to hear that. That means you're thinking, and you're well on your way to being a really good technician.
Oh, yeah.
So, yeah. Okay, so I'm gonna end the Zoom session for whoever's watching. Daniel, if you're watching, whoever may be watching this, we're trying hard to for y'all to connect by doing this, and hope you get clear soon to get back. But anyway, good to see you out there in YouTube land. And anyway, so we had we're gonna give it up here for Ty and for Alex. Woo, yeah. Okay, we're gonna give it up for them. Give them a hand clap. Ain't that right?
Yes, sir.
Taekwondo, take a bow there, man. So, hey, this is your man right here. Up and coming electrical technician,
Yes, sir.
maintenance technician.
Thank you, Mr. Brown.
Yes, sir. We're gonna try to. All right, y'all have a blessed day, and I hope to see you back soon. And I'll try to. We'll do our Zoom again tomorrow. So thanks for joining. This will be uploaded to YouTube later today, and you can watch it. The link is in Moodle. Will be in Moodle. Thank you.